Welcome back to geometry. We want to take a look at section 26 yet on coordinate geometry, and we will look at vertical line theorems and the equation of a line. So pretty straightforward here. 2 points lie on the same vertical line if and only if they have the same x coordinate. Of course, we're already familiar with that idea, so this sounds pretty good. But also, if we have a vertical line L, then M is a vertical line if and only if the two lines are parallel to one another. L is parallel to M. Or that L is in fact the same line as M. Okay, this doesn't seem like anything too spectacular, but it tells us a few different things. So first, the y-axis is a vertical line. Excellent. And all vertical lines are parallel to the y-axis. And all non-vertical lines must intersect the x-axis. And this one is probably the most interesting. But what really we're overlooking when we think about coordinate geometry is the fact that formally there is no orientation to the plane. There is no up, there is no down, there's no left, there is no right. What we do is we give it two particular lines. One of them we call the x-axis, and then we find another one that's perpendicular to it, and we call it the y-axis. And then we turn the coordinate system, or we reposition ourselves, or we set the lines in a good place to begin with, so that way the x-axis appears flat to our perspective, and that the y-axis is vertical to our perspective, right? Now with this particular orientation that we have assigned, there is something called a vertical line, a horizontal line, and so forth. And so here, what we're recognizing is, right, we've chosen a particular orientation of the coordinate plane. And that's really what we're saying here when we say these theorems on vertical lines. So it's not just about, of course, a line that's vertical that has the same x coordinate, and of course, two vertical lines are parallel to one another. Right? We're saying a little bit more than this. Right? We're again emphasizing or discussing implicitly the fact that there is an orientation to the plane. All right, so of particular interest to us is this last consequence of the vertical line theorems, and it's what allows us to very easily discuss the equation of a line. So, of course, the easiest thing to discuss, or what this tells us, is the equation of a line that's not vertical. But if we wanted to talk about the equation of a line that's not vertical, all that we have to do is consider the vertical line theorem here, the first one. They all have the same x coordinate, right? 2 points are on the same vertical line if they have the same x coordinate. So that's just saying the equation of a vertical line is x equals a. They all have the same x coordinate. That's it. So then if we wanted to talk about the equation of a line where that line is not a vertical line, we can do that. And it has a form that looks different than the one we just gave for a vertical line. So if L is non-vertical with slope n, it contains a unique intersection point with the y-axis, which can be written as 0, b. And then if xy is any point on the line, right? Xy is any point on the line, then we can write a relationship between x and y. Y is equal to m times x plus b. Y equals mx plus b. The equation of a line that we already knew. Excellent. But have we ever proven it before? Have you ever taken the time to prove it? Well, if you are actually, if you happen to be one of my students in a college algebra course, then yes, you would have actually. But I'm quite confident at this time that none of you were. So let's take a look at this. So we have, since L is not a vertical line, by the third consequence of theorem 26 point, what was it there, 26.3? Yep, vertical line theorems. Consequences of that, by the third consequence of that theorem, L intersects the y-axis. Excellent. But intersection points of lines are unique, right? If it's not the same line, they only have one point in common. So intersection points are unique. And of particular interest to us is that a point and a point on the y-axis has coordinates something comma something. And we know what this something comma something should look like for the most part. And it's a result of the fact that the y-axis is a vertical line. Well, the y-axis is a vertical line, so they all have the same x-coordinate. And what is that x-coordinate? Well, we chose the y-axis to be where the x-coordinate is 0. So the x-coordinate is 0. And then it's going to take on some well, it even could be 0, right? It's going to take on some real number b. So for some real number b. Excellent. Okay, well, let's let x comma y be any point on the line. Okay, easy enough, right? That's what our theorem is saying. The line has slope m, contains the unique point 0 comma b. Excellent. Yep, absolutely true. And xy is a point on the line. Excellent. So all we've done so far is discuss the assumptions that needed to be made. And we can write, let's see here, well, a couple of things here. I suppose one more or a couple more comments. Since x is not equal to 0, yes, okay, right, sorry. Looks like I need to make one little correction here. Let x comma y be any other point on the line. Okay, there we go. Now, since it's not a vertical line, x is certainly not equal to 0 because that coordinate's already being used and we're using another point. So let this be any other point on the line. Then x is not equal to 0 since L is not vertical. And the slope of L is, well, we already said that it's m, but we can calculate that using the 2 points. So we would have y value minus y value, y coordinate minus y coordinate, so y minus b divided by x coordinate minus x coordinate, x minus 0. Cool. How does that help us? Well, we can multiply both sides by x to get xm is equal to y minus b. And then, of course, we just need to add b to both sides to get y is equal to mx plus b. Ta-da! So the equation for a line results from using two particular points, particular, right? Only one of them is particular, using the intersection point with the y-axis, and any other point, we find that we can calculate the slope and rewrite that expression or rewrite that equation in this way. And that's it. That's all we were looking to show. Excellent. So as mentioned previously, we also know what the equation for a vertical line is. All right, but that's all that I wanted to share for this video. So I will see you guys again here soon, taking a look at coordinate geometry.